All right, so let's come up with an equation here that's kind of, I'm just going to make it up. Goodness knows what the answer is going to be. And I'm going to throw in some negative x's and some negative ones over here. I'm going to throw up a couple of positives over on this side. And let's put in two positives over here. Okay, messy equation. Fold my paper so I can draw it and do my symbolic. All right, so 2 negatives, 3 negative ones, my line, 4 positive x's, and 2 ones. Symbolically, negative 2x plus negative 3 equals 4x plus 2. All right. What do? Remember our goal. We have 1x on one side of the line and something on the other. That doesn't involve x's, right? We need to have a number over here and an x over here, or vice versa. Doesn't matter where the x falls, right? This side or this side. So we're looking for an x alone. Well, when we have x's on both sides, really the first thing we need to do is get all the x's on one side. Now, you know, sometimes it makes sense to make the left side the x side, and sometimes it makes sense to make the right side the x side. So what I do is I ask the students, the first thing we really need to do is pick an x side. Pick a side that's going to be your x side. And the reason why they really need to do that is what they'll end up doing is moving x's back and forth, back and forth, back and forth. If they don't say this is the x side and this is the constant side or the non-x side. So suppose they're stuck in a rut because we kind of do it this way all the time for them, and they say, well, the left has to be the x side. The x has to be in the left. Now, you and I are looking at this knowing, oh, no, pick the right, pick the right. But they picked the left. So let's go worst case scenario. So we have our x's over here. So then we say this isn't the x side. And I say what doesn't belong, right? What's over here or what's over here that doesn't belong on our non-x side? Well, all those x's. I could subtract them from both sides if I had enough positive x bars, but I don't. So what am I going to do to get rid of those x's? Well, we're going to do the same thing we did with the little ones. We're going to add the opposite to both sides to get our zero pairs and get rid of them. That means I need to add 4 negative bars, or 4 negative x's to this side. But to be fair, I got to add my 4 negative x's over here. All right, so I added 4, and I added negative 4, and I added negative 4. So draw it. 1, this is where it gets hard, and this is what encourages students to move away from the physical model. So that negative sign in the center means it's negative. Now, I did that because now I have 0 pair, 0 pair, 0 pair, 0 pair. And what I do is I actually circle up my 0 pairs. That together is 0, that together is 0, that together is 0. It does get messy. That together is 0. And if it's 0, I don't have to look at it anymore, right? It's gone. So what do I have now? I have 1, 2, 3, 4, 5, 6 negative x's, 3 negative ones, and 2 little ones left over here, right? Let's do that symbolically. What did I do? I added the opposite to these 4 x's to both sides. So I added negative 4x to both sides. This gives me negative 6x plus negative 3 on this side. And this side, that's a 0 pair. So all I have left is 2. Does this match this, match this? I hope so. I think so. Okay. So we're close. Now we're just to the 7th grade version of variable on one side and 2 steps to solve it. Now, we want to get rid of these 3. Remember what we did. We added the opposite. Anything we want to get rid of, we kind of add the opposite of it to get rid of it. So I'm going to add 3 to this side. Oh, did you catch me? I didn't add 3 on this side, did I? Don't make that mistake. Or don't let our students make that mistake. All right. So I added 3. I have my 3 0 pairs. So this is 0. So I'm going to circle them up. They're 0 all together. On this side, now I have 1, 2, 3, 4, 5. Let's do that symbolically. I added 3 to both sides of the equation. I end up with negative 6x. That's 0 equals 5. We're almost there. Now remember, when we didn't have enough bars for all the tiles we had, and they didn't divide evenly. So I'm going to try to divide these guys up, and I don't have anywhere near what I need. So as an 8th grader, they need to understand what we're doing here with this concept. We're taking 6 negative bars and we're dividing 1, 2, 3, 4, 5 tiles evenly among those 6 bars. Right? So I'm taking 5 and I'm dividing them 6 ways. Right? So 1 6, 1 6, 1 6, 1 6, 1 6, 1 6 from you, 1 6 from you. So each of these is divided into 6. One of them goes with each of the 6 negatives. So I'll have 1 6 from you, I'll have 1 6 from you, 1 6 from you, 1 6 from you, 1 6 from you. So the way that looks, or ends up looking, is I have negative x and 5 6 from each of these little tiles. Does that make sense? Well, let's look. If I divide this by 6, right? Divide this by 6, I'll have negative x is representing 5 6. Okay, so there's our little rational piece. Now, we got that negative sign. Anybody worried about the fact that I have a negative sign? So, if I have a negative sign here, I'm just going to focus in and say I have negative x equals positive 1. How do I get rid of the negative? Well, remember where what we wanted is. It's on the back, right? So really, all I want to do is flip this one over, right? But we have to be fair, right? I can't just flip this guy around anytime I want to, right? Well, if I flip this one over, what do you think I have to do over here? Yeah, that's right. Flip it over. And look what we end up with. We end up with positive x equals negative 1. Well, let's see what that looks like symbolically. Flipping it over is going to its opposite, isn't it? The opposite is on the back. So when I want to find the opposite of something or represent that symbolically, I put a negative in front of it. So I'm going to find the opposite of negative x, and I'm going to find the opposite of 5 6, and the opposite of negative x is positive x, and the opposite of 5 6 is negative 5 6. Now, I think I've got it. I think it works. I've got a positive number, and that's going to be flipped, so I have positive negative 5 6. All right, you've kind of seen every trick in the book in this one, except one.